Hello, my name is Jason Chonko and I'm the Applications Marketing Manager at Siglent Technologies North America. In today's video, we're going to take a deeper look at the SDS5000X series of oscilloscopes, which was recently introduced. The SDS5000 series is our new flagship series with bandwidths up to 1 gigahertz. So it's available in 350, 500, and 1 gigahertz. So 350 meg, 500 meg, 1 gigahertz, up to 5 gigasamples per second. 2 analog channels or 4 analog channels are available, as well as mixed signal support. There's also 2 USB ports on the front that can be used with a USB stick for a memory device to save images and data, as well as saving setups. And this scope also supports keyboard and mouse control. So we could connect a keyboard here and be able to type in labels, use a key or use a mouse very similar to our finger. This also supports touchscreen. So you can see some of our pictures or some of our menu-driven items here. Also, we can adjust the location of the waveform trace. We can also pinch and zoom. In this case, we have a PRBS or pseudo-random bit sequence, so we have lots of different bits showing up on the display. I'm using one of our generators, the SDS5000 series, to source this particular waveform. And I'd like to just show you some of the features. Some of the new features here of this oscilloscope, we have channel labeling. So we can bring up one of the analog channels. I'm just going to press on that channel, and you'll see the menu pops out. We can go to label, and here we can go to label text. We could type in label text. I'm just going to put test 1 and hit enter. Okay, so now our text shows up here. We can then change channel 1, C1, to test, and you can see that located here. So we can label each one of our analog channels, or our digital channels, or our math channels. All of those can be renamed directly using this direct labeling. So very helpful if you're doing test reports and you have multiple channels. Just trying to be able to remember what channel can sometimes be a challenge, so that helps you out in that particular regard. We also have some fairly extensive cursors here. We're just going to turn on the X and Y. And again, we're just trying to make things easier for your on-screen viewing. To move the cursors, you can simply drag them back and forth. We can also move labels for each individual cursor. We can lengthen and contract. We can also change the display type. This is M2. We can change it to M1. And now we have a concise version, and we can move that anywhere on screen. So that can also be very useful for you if you happen to be looking for, looking to take different pictures or key in on specific areas on the display. The touch can also be disabled if that happens to get in your way. You can disable the touch. If your colleagues are always pressing the screen, you can turn that off, so make that a little bit easier for them. So now let's take another look. We have got this pseudo-random bit sequence. What I would like to show you is some of the deeper measurement capabilities of this particular box. So we're just going to open up measure. Again, these bits are just changing over time. I'm going to go to the menu for measure. And that's going to open up here, measure all. We're just going to go to custom measure. And now you'll see the different types of measurements that are available. These are the verticals, these are the horizontals, and here we've got the channel delays. We're just going to take a look at the pulse width in this case. And we're going to close that pulse width. So now this last value is pulse width. I'm just going to close off these other values. So now we're just looking at width. Now we can turn on statistics, and we can turn on a histogram. Both statistics and the histogram are new. And you'll see with each trigger event, we're actually incrementing quite a bit here. I'm going to put the scope into a longer time base, and I'm just going to go a single measurement. So a single trigger event. All of this data was captured with a single trigger event. And now we'll take a look at the histogram. And you can see now we've got each one of these has been binned. We can also move the histogram values around the screen again to make room or to make areas so we can take a look at the actual data that we're looking at, or move things around to make it easier for that. We've got all of these bins available immediately. Now we've stopped the acquisition. We don't have any more data. I can actually reset the statistics here, and you'll see that we have 129 different pulse widths, or different pulses that we've measured here. This can actually measure deep memory. We've received or calculated all of these, or measured all of these pulse widths with a single event. So that can be very useful. Again, we could just update that with single. We can actually shrink it down and then take a look at our, we'll do the reset. And now we only have 3 pulses, 1, 2, 3 full pulses And now we can see their individual pulse widths located here on this display. So whatever we have on the display, up to 1000, we can then, again, I have not readjusted my acquisition, I'm just resetting the statistics and calculating. So now we've got 137. So in a way you can use it as a pulse counter as well as a pulse discriminator. Now we can see exactly what our pulse widths are in this particular sample. So really, the analysis package on this oscilloscope is extremely powerful and deep, especially with the horizontal menu being able to measure multiple places like that. So another area that we have here, I'm going to take a look at the trigger. You'll see we're triggering on a rising edge, and a way that we can make this a little bit more stable or a little more selective, we can go to trigger. We've got a number of triggers available that we have on a lot of other oscilloscopes. Some of the different ones here, we have qualified. Qualified trigger allows you to select a value on one channel and then a discriminating value on a secondary channel. So it actually could take two events on two separate trigger or two separate inputs and then evaluate it. So for example, state with delay would mean that a channel would have to be in a certain state for a certain period of time before it evaluates the next value or the next trigger event that you have. So another way to sort of hone in exactly on what we're looking for. But in this case, what I wanted to show was the zone trigger. Zone trigger is used after the initial trigger has been evaluated. So again, rising edge is one of the very common triggers. I'm just going to put this in normal, and I think I need to get back to rising edge. Rising edge trigger. And now I'm going to enable zone, and you'll see we've got lots of data going on here. Now I've got the zone trigger is going to allow me to draw a box on the screen and then select whether it must intersect or must not intersect in this zone. I'm going to say must intersect in this zone, and you'll see that as I move it, we'll actually get a little bit different values here. Now I'm going to turn on 2, and I'm going to turn on not intersect, and I'm going to draw another box that says must not intersect. And now you'll see that it's only going to trigger when events occur that meet the rising edge, meet the intersect, and meet the not intersect. And I can then move this around on screen and push those values around. So you'll see it'll actually change where I'm triggering based on where I put those zone triggers. So again, the zone triggers can be added to the rising edge or other triggers in order to qualify or make it filter out those events that we don't want to see. And again, we can go intersect or non-intersect for both this zone and that zone. So again, can be quite helpful. We can also disable the zone very quickly just by simply going off. And to slide that back, we're just going to press the screen and everything will come back on. If we want to add a second channel, we can simply press that key and select channel 2. So now we're going to add channel 2. We can add channel 3, etc. And to disable the channel, we can just go to off and off. So the touchscreen is very nice, easy to work with, and makes things quite a bit easier for us. Now I've set up a little bit of a different waveform. In this case, we're looking at a 500 megahertz carrier with 100 megahertz modulation. And I'm just going to shrink this in a little bit. Acquisition memory, I've set the memory depth to 250 megapoints. So that's going to be, again, displayed over 2 channels. So if we had 2 channels active, it gets cut in half. But 250 for these 2 channels, 250 for these 2 channels. And now I'm going to zip in and take a look at, I'm just zooming, so you can press the horizontal to zoom in. And now I'm going to take a look at the measures. So we can go custom measure, and we're just going to change the source of the measurement to zoom. Zoom trace 1. And I'm going to change that back from, I'll go to frequency. And now we'll see that we're at 500 megahertz. I'll turn off the histogram and the statistics. So you can see 500 megahertz. So the first values, the time base that I've collected that data on originally is 10 milliseconds per division. So we've got 14 divisions on the top. So 140 milliseconds of data. We're drilling down to 500 picoseconds here. So with that memory depth, we're able to capture a very long time base and then have a lot of detail over a very small part of that particular waveform that's been collected. And that can be very powerful if we only have one opportunity to collect data. Now we can collect it and drill into each individual part separately. And like many of our oscilloscopes, we also have color display mode. And so color display mode, display persist, turn on that color gradient, and now events that occur frequently are going to be colored red, and events that occur infrequently are going to be blue. So as we get a lot of overlap on those data points, we'll get a lot of the red coloring, which is again where we're getting overlap, which can also help you to see what's going on, the frequency of the events that are occurring.